Okay, so after doing this question with the reduction of order method, we can use the same. We can do the same question with the reduction of order formula. So the reduction of order formula is this: we calculate the u prime, and then later on we will integrate. Then we will calculate the small u, and then from small u can calculate the y2. So for the reduction of order method, so what we can do is, let me start from here. I write down the equation. So this is the equation. So there is some mistake here. So yes, so now we have this equation. So using this equation, then we can find the u. So but this reduction of order formula uses this p. Okay, so what is p? So p is the ratio of the coefficient of y double prime, and then coefficient of y double prime is divided throughout. Okay, so it will be 2 into 1 plus x. So it will be p. Yeah, so it will be p. So it will be 2 into 1 plus x over 1 minus. So this will be the p. So now we can apply the reduction of order formula. So u is equal to 1 divided by, maybe I write it in a little bit formatted way, 1 divided by y1 square, y1 square. Then it will be exponent, and then in the exponent we have the integrate, and integrate is minus p. Okay, or it can be minus, it can be inside or can be outside as well. So let's do it outside, minus p. Okay, minus integrate, and it will be p, and then it will be with respect to x. So plus, and then divide it. So in this way we have found the value of capital U. So from the value of capital U, we can find the value of small u by integrating the capital U. So integrate capital U, integrate capital U with respect to x. So this will be the small u, and from small u we can calculate the y2, that is the second solution, which is equal to y1 times u. So this will be the answer. We need to simplify it. Simplify. There should be one more slash. Yeah, so we get this 2 plus x square, which is the same solution as before. So as you can see that using the reduction of order formula, it was much quicker to find the solution rather than the reduction of order method. Okay, so now let's look at this variation of parameters method. So this is the equation, and then we want to solve it with the variation of parameters method. So let's input this equation over here, and this is how it looks like. So naturally there are something happening because I am using those variables which are in the memory. So I need to remove those things from here. So in order to fix this error, maybe we can use clear command. We can clear y double prime, y prime, y, and t, etc. I don't know, I don't think we have used t, so let's clear it. And now we can use this command. So this is the equation, okay, y plus y2 prime. So this is the equation. So next we can write the characteristic equation for homogeneous solution. So the characteristic equation, we can manually write it. 1 plus 2m plus m square is equal to 0. Okay, so this is the characteristic equation. We can equate it with the variable CE. Okay, and then solve for m. Solve CE for m, and then we get values of m1. M is equal to -1 and m is equal to -1. So this gives us solutions y1 as this. Okay, y1 is equal to e power -2 t, and the solution y2, because it is a double root, so the second solution should be multiplied by t. So this is the second solution. Okay, so for the calculation of Wronskian, so we need to calculate the first derivatives of y1 and y2. So first derivative of y1, maybe we can represent by y1 prime. We can represent by y1 prime, so this will be the first derivative, and of y1. The first derivative of y2 we can represent like this: y1 prime is equal to dy1 and then dy2 with respect to t. So in this way we can calculate the Wronskian. Wronskian is given by y1 y2 prime minus y2 y1 prime. So we can write the equation of the Wronskian here. So this is y1 y2 prime minus y2 y1 prime, and then simplify it. So we will get the Wronskian e power -2t. And now we can find the particular solution yp. So for the particular solution, we need to write the variation of parameters, variation of parameters formula. Okay, so the formula for the variation of parameters is this. So for example, yp is equal to -y1 integration sign y2 into r over w into t, and y2 integrate y1 into r over w. But here actually we have not yet defined r. So what is r? R is the right hand side of the equation. So this is r. So we can define r here as r is equal to e power -t log of t. So we can define r here. Okay, so now we have the value of r. So this is the variation of parameter formula with simplify switch. We can execute this formula, so we will get the yp. So this will be the value of yp, and yh was c1 times y1 plus c2 times y2. Okay, so we can write h as c1 times y1 and then c2 times y2. So this is yh. So it is this one, and then total function is equal to yh plus yp. So this will be the answer in the variation of parameter by the variation of parameters method. So if you like, you can also verify this answer